How do polar stratospheric clouds impact the ozone layer? Imagine a winter sky over the polar regions, filled with strange, wispy clouds high above the Earth. These are polar stratospheric clouds, and they play a big role in how the ozone layer changes over the poles. These clouds form during the coldest months when temperatures drop below -80 degrees Celsius. Such extreme cold is only found in the stratosphere over the poles because the air there is very dry and thin. Water vapor and nitric acid in the air condense into tiny ice particles, creating these clouds. They look like faint, purple or pink streaks in the sky, but their impact on the ozone layer is much more important. The surface of these clouds provides a perfect place for chemical reactions to happen. They activate chlorine and bromine compounds that are usually safe in the atmosphere. These chemicals come from human-made substances like chlorofluorocarbons, which are used in refrigerants and aerosols. When these compounds are on the surface of polar stratospheric clouds, they turn into free radicals, which are highly reactive. These radicals then attack ozone molecules, breaking them apart into oxygen. This process causes the ozone layer to thin, especially during the spring when sunlight returns to the poles. The sunlight triggers the reactions that destroy ozone, making the ozone hole over Antarctica much larger during certain times of the year. The clouds also help remove nitric acid and water from the stratosphere in a process called denitrification and dehydration. This removal prevents the formation of chlorine reservoir compounds, which would normally slow down ozone destruction. So, the presence of these clouds actually prolongs the period of ozone depletion. The seasonal cycle is key here. During winter, the clouds form and set the stage for ozone destruction. When spring arrives, sunlight kicks off the chemical reactions, leading to rapid ozone loss. As summer comes, warmer temperatures and atmospheric mixing help rebuild the ozone layer. The extreme cold and stable air over the polar regions create the perfect conditions for these clouds to form and influence ozone levels. Over Antarctica, the conditions are especially ideal, leading to the famous ozone hole. In the Arctic, the situation is less severe because the temperatures are not as consistently cold, and the land sea distribution affects cloud formation. Understanding how polar stratospheric clouds impact the ozone layer helps scientists monitor recovery efforts. Since the signing of the Montreal Protocol, which reduced the use of ozone-depleting substances, the ozone layer is slowly healing. However, climate change could make the stratosphere colder, potentially increasing the formation of these clouds and affecting how quickly the ozone layer recovers. So, these tiny clouds are not just beautiful but also powerful players in the story of Earth's atmosphere and climate.